Away on question, I'm going to be starting straight away on questions 11 and 12 here, okay? Now, 11 and 12 is very simple. The biggest side squared always equals the two smaller sides squared and added together. Only when it's a triangle with a 90-degree angle in it. Has to be 90 degrees, otherwise Pythagoras' theorem never works. Has to be 90, okay? So you're going to get 12 squared plus y squared. We're going to get 400 equals 144 plus y squared. We then take away 144 when we bring it over to the other side. That will leave us with 236. Y squared is therefore going to be the square root of 236. Okay? So it's going to be 400 minus 144. I'll say 144. And that is going to be a square root of, 256. That's why it's always wise to double check with the calculator. Okay? 256. Square root 256. And your answer is going to be 16. The next length is 16. You do the same thing for the next one. H is the longest side. So you're going to get h squared equals 1.4 squared plus 4.8 squared. Once again, just go straight into the calculator with 1.4 squared plus 4.8 squared. And what you're going to be left with here is 25. H squared equals 25. Therefore, H must equal 5. Most part, everybody here is getting them. Okay? Pretty much everybody. Okay? Next question on is going to be numbers 23 and 24. Which you'll find difficult, okay? Now, in number 23 and 24, they're squares, okay? Now, in number 23, when you have a square, okay? When you have a square, and it's a standard square, when you put a diagonal from side to side, what you usually know is the side of the square. So let's say the side of this square is 3, and this one's 3. This will mean you can use Pythagoras' theorem to find out the length of the diagonal. So you can say that x squared equals 3 squared plus 3 squared. X squared therefore equals 18, and x would equal root 18. Okay, so that's how you'd find that. But in these questions here, we're told the diagonal, and what we have to do is we have to find the length of the square. So it's a different type of question, okay? So what we're going to do here is root 32 squared equals what? X squared plus?
X squared what?
Okay. The largest side squared equals the two smaller sides squared and then added together. Okay, so we're going to get 32 equals 2x squared. Divide across by x squared plus x squared is 2x squared. Divide in by 2 and we get x squared equals 16. X therefore equals? It's technically plus or minus 4, but why can't it be minus 4? Can't have a minus length, so it's x equals 4. Okay guys, what about the next one? It's same deal, it's a square. So if it's a square, what does that mean about the bottom one? It's the same question, isn't it? Yeah. So are you happy enough for me to skip the next one?
No.
Okay. Root 50 squared equals x squared plus x squared. 50 equals 2x squared. Divide by 2. 25 therefore equals x squared. X equals 5. You can see that it's actually the exact same question. Okay? Now, where most of your problems are going to come in this chapter is the written ones, to give you these written ones where you have to figure out different. It's the language that's going to get you. Misinterpreting the questions is what's going to cause you hassle in this chapter. Okay, so that brings me on to this question here. It looks easy, but there's something that's wrong with it. If this is a right-angled triangle, it has to obey Pythagoras' theorem. If it doesn't obey Pythagoras' theorem, it therefore cannot be a right-angled triangle. So for example, if I take this one here, what's the longest side? So write down 13 squared, then write down that equals 6 squared plus 12 squared. Use your calculator and check if both sides equal each other. If they equal each other, Pythagoras' theorem works, and it means the right angle triangle. If they don't equal, it means Pythagoras' theorem doesn't work, and the triangle you're talking about cannot be a right angle triangle. They're using this a lot in the past papers. Use a theorem to prove that this is not a triangle. This is one of the ones they'll ask. Alright? So it's going to be 13 squared equals 12 squared plus 6 squared. 169 equals 144 plus 36. Add them together and what happens? Is this right hand side equal to 169? No. It was equal to 180. This means, because it doesn't balance, this means that this isn't a right angle triangle. That's what you need to remember, right? If it's a right angle triangle, Pythagoras' theorem has to work. Can I move on?
Sure.
Yeah. Cool. Okay. Next one, okay, is back when we did area of a parallelogram in the area section. It isn't something you have to memorize off by heart, because there's you have your log tables. Okay. So if you're given a parallelogram, and I told you that the base is 20 long, and it's not the height that you're worried about. If I said that's 15, you don't multiply 15 by 20. That's not what you're looking to do. What you're looking to do is multiply the base length by the vertical height. So if I said the vertical height was 12, what's the area of this parallelogram? It's going to be 12 by 20, which is 240. Now this brings us to questions 28, 30 and 31. Basically we have the same type of question here, okay? Now what the error they're looking to draw from you is this. When people do number 31, a certain amount of the population just go 17 multiplied by 20 to get it wrong. The problem is I need to find out what h is. And as we know, this is the Pythagoras theorem exercise, which therefore means that we're going to do the longest side squared equals the two shorter sides squared and added together. You're going to put in 17 squared, I think it's 341. 289. Okay, 289 equals h squared plus 64. Bring the 64 over the other side. Take away your 64 and you get 225. H squared equals 225 because it comes minus 64. H therefore is 15. The height is 15. Now what's the area of this parallelogram then? Anybody? 20 by 15, which is 300. And it says in centimeters, so 300 centimeters squared. Is that right? Cool. Okay. Now, up to question 30, all the questions more or less stay the same. They're just one method for each section. The next part is going to be basically the language gets more complicated and become much more wordy. And that's where the problems will kick in, if there is to be problems. So if you look at number 36 now, what you can see is it says PR is root 97, which it is. PQ is 4. PT and TS is 5. So they're the same length as each other. Okay. PQ is perpendicular to RT. What does that mean? PQ is perpendicular to RT. It means that that's 90 degrees and that one there is also 90 degrees. It's already marked in, but they don't have to mark it in if it's in the description of the question. Okay? Shh. Lads, calculate QT. Now where's QT located? Here. What type of triangle are we looking at there? Sorry? Right angle triangle. So, Keane, what's the Pythagoras theorem for this one? What do we start off with? It's the red triangle.
5 squared.
Yeah, equals
4 squared.
Yeah.
Equals x squared.
Okay. 25, 16, and x squared. What does x squared have to equal to balance that up?
Yeah.
25 minus 16 is 9. X equals, anyway, 3. So look guys, you're going to use that for 3. And then you're going to find out what QR is next. How do you find out what QR is? And we're going to call that Y. How do you find out QR? And your triangle this time is going to be root 97, Y and 4. So how do you start off this one, James?
97, root 97 squared.
Yeah.
Equals 4 squared.
Yeah.
Plus Y squared.
Fair enough. Root 97 squared is 97. 4 squared.
16.
Okay. 97 minus 16. 81. 81 equals Y squared. Y therefore is 9. Equals 9. Okay. Now that we know that Y is 9, what is R to T then? R all the way down to T?
12.
12. Okay, because it's your 9 plus your 3. And then finally we're looking to get RS. And RS, okay, we're going to turn into just a green triangle here, okay? So it's going to be 12 down, 5 across. Okay, so what we can do here is 12 down, 5 across. And we're looking to find out, we'll call this Z this time. So let RS be Z. So Cian, will you, Gallagher, will you take the reins on this one for me, please? The green triangle, what you put in first? It's a Z, by the way.
And you just move the other one in.
Okay. Gavin?
12 squared.
Which one's the longest side? By eyesight.
Z.
Z squared equals?
12 squared.
Plus?
12 squared.
Alright. And then you put that into the calculator and you get 169. And what's the square root of 169? 13. Z equals 13. Okay? One last question. Then you guys are working for the rest of the class, okay? Alright. This one here, okay, which is number 39. In the diagram, the length of the larger square is 31. Calculate, number 1 is the perimeter, and 2, the area of the smaller square. The smaller square being bang in the middle. David Cotterill, what can you tell me about this length? I'm just about to put my pen there now. What can you tell me about this length here? Here to here? 7. Now see the way this has one line through it? That means any line that has that one line through it is also 7. So what other ones are 7? That one there. Now what about the double line? What ones are the same as the double line? 24, 24, 24. Now the next thing, guys, is we have a triangle now, and how do we find out the length of the inside square? Let's call the length of the inside square x. Do you notice that all the triangles are the same? They're all 24 and 7. So do Pythagoras' theorem. So Cian, what is it?
24 squared.
No, which is the longest side by eyesight? Not by number, but x is the longest side, okay? And then what?
24 squared.
Yeah.
Plus 7 squared.
Yeah. And what does that equal in the calculator? You can read it out in a second, I suppose. 600 and? 625. X squared equals 625. And what is the square root of 625? 25. This means that this inside square, which is here, and it just basically has just a bit of a rotation on it as well. Its length is 25 all the way across. What does that mean about its perimeter? What is it? If you do a lap of this, how many centimeters have you covered? 100. Perimeter is 100. And finally, what is the area? Length multiplied by width. 625. Okay, guys.